Welcome to the second tutorial video of the Modular-X machine vision software. This video is going to demonstrate the optical quality control of a connector. These pictures were taken from the production line, so this is a real example, a really good way to learn the basics of image processing. First of all, before we begin, let's take a look at the connector and its quality problems. We are going to use the Simulate tab to acquire the images from our hard disk. Let's select Forward to cycle through forward and the images in the folder. So let's select this image here, then click on the Accept button. This connector has two soldering points here and the resistive material in the middle. We have to check the quality of the soldering, if there is enough solder, and look for burns and contamination around the pins. For example, this is a contamination, and also let's look for some burns on the image like this one here. You can download these pictures, so if you want you can follow the instructions of this video. So let's begin to build our inspection. The first task you have to do is to build a coordinate system, because the connector doesn't appear in the same position on the image, and to provide that the region of interest of the functions will check always the specified area, it is necessary to use a coordinate system. I'll show you some tricks how to do it in this case. I think the easiest way now is to look for two straight edges on the resistive material here, and then use the geometric functions to get the intersection of the edges and build up the coordinate system here. To do this, first have to use the function called match pattern to positionate these straight edge functions. You can find the match pattern here. This step is going to store a template image on the computer and then compares it in a given region of interest on the acquired image. It is given by the user. It returns with a score value that shows the match of the pattern and the found feature. Let's just click on the new template button. It is going to open up a window and select the template region here. Let's go through all tabs. Define pattern matching mask. It's not necessary now in this case, and then click on File and Save Template As. Now you can close this window, and then let's set up the region of interest. Just draw in the image. This part is going to be enough, and check out the parameters here. Let's set the search level to 4, and this is the search for rotated patterns. The angle is 25. This is the default value. It's going to be OK, and set the overlay on the image. Disable the search area, the feature found in the label. We want to see only the result to make sure that the function found the feature in the image or not. And now click on the Accept button, and we have to build up a coordinate system. Let's select the Locate Features and Coordinate System. Positionate the process is going to be this one, because we have to positionate this horizontally and vertically also. Select the match pattern, click on the Accept button, and now we can positionate the straight edge functions here. In the Locate Features you can find it, and look for the left edge here. Let's just draw a region of interest and set up the parameters. This is going to be fine. Left to right, get the best edge, and the polarity is bright to dark only. Set the edge range to 30, and it indicates that it found the edge on the image. And let's use the reference system it's okay, and then disable the search area, the search lines, the feature found in the label. We want to see only the result to make sure that it found the edge correctly or not, and then click on the accept button. But before, let's give a name like left edge. Now accept. Let's do this with the bottom edge, straight edge again, draw the region of interest, positionate it, and then bottom to top, this range is 30. Yeah, it found quite well. You can set a bit lower, get the best edge, bright to dark only, use the reference system, the coordinate system 0 that we developed here on the match pattern function. Give a name like bottom edge, and set the overlay on the image, disable the search area, the search lines, the feature found in the label. Click on the accept button, and now let's go through the images in the folder if it finds it correctly. No, something is wrong. Let's go back to the match pattern, because something might be wrong here. Maybe set the score value to a lower value like 600. Now let's check it out. Yes, it finds it, but now there is some problem with the edge on the bottom here. So let's just check it out. Was wrong. Yes, it's not in the correct position, so let's just move over there. Now it works fine. Yes, and once you done with this, just select bottom edge and then measure features, geometry, and let's use the feature line intersection and select the points according to this figure here. It's like 4, 5, and 2, 3. 4, 5, 2, 3, and this is going to be the origami geometry. Yes, click on the accept button, and let's build up a coordinate system. This is going to be the origami. Select the origami geometry, and now select the process mode. It's like position it horizontally, vertically, and also the angle, and click on the accept button. Once we finished our task with coordinate systems, we can disable the overlays of the function and focus on the quality control. So let's just go through all steps. Disable the result here. Of course, it's 0 the result and the label. Left edge. Just do the same for all. Feature found, result, and label. And now we can see just the origami. And to detect the burn part of the image, let's use a measure feature called intensity measurement on the image. Just set up a region of interest by drawing on the image. Just resize a little bit, and this is gonna be fine. Let's move to the position. Use the reference system, origami, Let's name it like check burns, and use the standard deviation to check if it's burned or not. Click on the accept button, and now if we go through the images, you can open this tab, and here you can see the standard deviation of the region of interest, and the position is not the best now. So let's go back to the coordinate system and use another reference angle. Use the bottom edge, click on the accept button, and position it again to the area you might want to inspect. It's here. Click on the accept button. Let's roll over the images. Let's check the value, and you can see when it's burned, the standard deviation value is 11. In other case, it's lower than 11. So in every step that makes a measurement, there is a condition. And set this to 0 to 10, and it will pass the inspection when this value is between 0 and 10. Click on the accept button, and now let's roll over the images, and when it burned, it writes that it is out of range. So we done this part. Also, to check the contamination on the image, let's use again the measure features, intensity, and draw a region of interest. You can use different type of region interest here. For example, this is a rectangle, but you can rotate it and rotate in the angle, resize it. It's in the good position. Use the reference system, or we go and give a name like check contamination. Take the standard deviation, let's measure, open the step. There you can see the values, and when the contamination appears on the image, it is 26. So let's go back to the step, and let's write that when it's between 0 and 25, this part will pass. Let's check it out how it works. Yes, and this is out of range. And now it's time to check the soldering on the image. We are going to do by that when there is enough solder on the pad, this dark area appears on the image. So there is a function called detect objects in the locate features here. Let's draw a region of interest on the image. Use the reference systems, Origo. Let's name it like check bottom solder, and because we are looking for a dark area, let's set this to dark objects, and then set the threshold value to 65. Disable the ignore objects touching the region of interest, and now it found the object because there is a red rectangle and also the red point over here. And let's check it out. The area is 12,610. So let's set the minimum object size to 8,000, and the minimum number of objects should be 1. So it is going to pass this inspection when we found minimum 1 object in the region of interest. So now let's just click on the accept button. Let's figure it out how it works. So there isn't enough solder on this pad, and it's bright, and it says too few objects found in the image. There is enough solder now. Yes, it works pretty well. Now let's copy this step by pressing the Ctrl C and then Ctrl V. Let's rename it check top solder, and delete this copy here, and move the region of interest to the top solder. Let's rotate a bit. You can also resize a bit, and click on the accept button. Let's figure it out how they work. So on the bottom there is 1 object, and also on the top there is 1 object. On the top, too few objects found because there isn't enough solder. So I think it works pretty well now. You can close these tabs, and now we have to set the session status over here. You can do that by 2 steps. In this case, by opening the additional tools and logical calculator, we add the step results over here to this table, like select measurement, check top solder, step status. When it's passed, it's going to be passed true. So add all results to the table. Check contamination step result. It's true. And now you can just type the names of these results here, like A0 and B0 and C0. This is going to make the logical connections of these values, and let's name it like calc session status. Yes, click on the accept button, and if you want to set this indicator, you can do that by setting the session status with the session status step. Let's name set session status and select equals specified measurement and the calc session status step logical result over here. Click on the accept button, and let's see how it works. Let's roll over the images. We haven't got enough solder here, so the session status is fail. We have contamination here, so the session status fail. We don't have enough solder here. Now the check burn is missing from the table, so let's go back to the calculate session status tab, add the result of the check burns step status. When it's true, it should be true, but now it's false, and the 0 accept. Now let's roll over the images. There is a burn, and it fails because this step has failed because it is out of the range. So I think we finished. Let's test our inspection on all the images. All images. We can find good parts here. Let's let's just roll over from here forward, accept. Let's check out how it works. You don't have enough solder in the bottom. This part is burned. Not enough solder in the top. It's perfect. No contamination. Yes, so this is how it works. I hope it was helpful, and keep updated because we're going to post more videos about how to use the Modular-X. So thank you for watching this video, and I wish the best for you. Bye.